So I'm laying out my first wall, and right here I've got my top plate on end. We want to lay out the studs, which are of the same material as this, and we know at the beginning of the wall there will be a stud, so we can mark that with an X. Usually I'd be using a pencil, but for demonstration purposes Sharpie does the trick. Now, a mistake you can make is that most people think, well, okay, well we started here, so we can put an X just afterwards, and that'll be the first stud, so therefore we can come 16 inch, which is 16 inch on centre, mark it up, and then put an X there. Now that would serve to have the 16 inch on centre, as the first stud, the centre of it would be there, and the second stud, the 16 inch centre, would be in the middle. But unfortunately we can't do that because of the backer board that goes on the back. Now that needs to come to the very end. As it comes in 8-foot boards, which is a multiple of 16 inches, we would find that if at 8 feet down the other end, it would come all the way to here, which would be the middle of this, but we don't want that. We want it to come all the way to the end. So what the first thing to do is to measure how thick your top plate is, or bottom plate, or indeed all the studs. And most are 2 by something, whether you're using 2 by 4 or 2 by 6. You'll find that their 2 inches is regularized to 1.5, and mine is 1 3/4, i.e. 44-45 millimeters. That's quite usual in the UK to have boards this size. So we might see other videos which say come back 3/4 of an inch, which is half of the depth of a 1.5 inch, i.e. a 2 by 4. But in this case I have to come back 22 millimeters from the 16 inches to there, which is 7/8. So 22 millimeters is the same as 7/8. So I can mark this, and I can stick my stud to the right of that. Now, as we move forward, we'll go from 16 to 32, which is our next stud, and then we want to do exactly the same thing, and that is to come back 7/8 of an inch, i.e. 22 mils, mark that, and put the stud there. Now we can see, when we put the studs, we put the tape measure there, we can see that the centre of this stud is 16 inches to the centre of this stud. Now that's 16 inch on centre. Now the same doesn't apply for the first 2 studs. If I put this in the middle of the first stud, you'll see that the 16 inches comes there. So the first and the second stud aren't actually 16 inch on centre, but thereafter they are. But just to reiterate, the reason for that is because the 8-foot sheet needs to come all the way to the end, not just to halfway along the stud. So you can carry on with this layout all the way to 32, and most tape measures have the 16 inches marked. So I've got a diamond on mine. On some tape measures, especially in the US, it's more obvious. And we can come back 7/8 and put an X again, and then we can carry on like that all the way. When you get to the end of your tape measure or the end of one of your boards and you want to go to the next board, the thing to do but to go to the end, and at that point you can put the 16 inch there and then put an X to the side of it, and that makes it a bit easier. You don't have to come back, 7/8 or whatever the half the thickness of your boards are. You can just go to your 16 and then put an X on the other side, and it's well worth putting the X, because then you know which side of the mark that your stud actually goes. So if you're realigning your tape measure down the line, you can just put it on the end, and then you can mark 16 and like that. If you prefer that, if you've got a funny sort of sized board which doesn't really sort of line up with anything on your tape measure very easily, especially if you're doing inches, then you can mark your first one, come back half your board, and then from then on put a nail in, stick your tape measure on it, and then you're sorted. You can just go 16 inch, put an X to the right of it, and carry on 32 inches, put a mark and an X to the right of it. So now I've got my bottom plate and my top plate lined up together, and they're nice and flush on the end, which is important because you want everything to line up nicely to stop the wall being out of sync. So what we want to do is actually now transfer our lines from the ones we've made here across. So we know that this is an X, we don't need to mark a line, we know that this butts up to the other side, so we can put our X there, we know it's there. From here on out we want to take our speed square or whatever you've got. This is a very old-fashioned one, I'll grant you. I think it was my grandfather's. And we line it up and we put our line across and make sure it's nice and accurate, and then we can put our X there and we know our studs going there. And then we work along plates doing the same thing and putting our X. So now I've come to the other end of the plate, marking my 16 inches all the way along. Now I've got to this one, and after this the next 16 inches is off the end. These are 4.8 metre lengths. So the thing to do is, I'll just mark this up so you can see it more clearly, is the stud ends here. So what we don't want is a floating top plate which doesn't have, at the end, doesn't have a stud to support the top. And we don't want to disrupt our 16-inch centre. So what we're going to do is cut off at 1 3/4, which is the width of this, turn sideways where the stud will be, 1 3/4 along here, and that'll be the end of this plate. Now this is for the back wall here, and you can see it's a little bit short, but it's not quite coming to the end here. So I'm going to have to add a new length here and put up the wall in 2 stages and attach the two together. Now you can cut the top plate half the width of this shorter than the bottom plate, then overlap the next one over the same stud so that this top plate is half on top of the first stud, on top of this side of the stud, and then the other plate comes over and sits on the other side, and you screw in like that or nail in. In this instance I think it's better just to be able to end it here, start with a new stud, but then carry on a 16-inch centre from here to the next one. So we spread the bottom plate and the top plate apart, and by using our marks that we made earlier we can put our studs in the right place to go between the two, and cut to measure, and you obviously have to take into account the size of both the bottom plate, the top plate, and the double top plate. There'll be another piece here which I will show you the reason for. Is where you don't have timber that is long enough to go the full length of the wall, you're going to have to create 2 timbers and have the 2 sections of wall together here. And what you can do here is have 1 stud going down the centre and then sort of toe nailing in from each side. You can do the same at the top. But for me, for the price of what, £3 for half a stud, half a timber, it's just better to double it up, and then you can screw through both sides or nail, and you've got a much more solid wall when you put the two together. But when we're talking about our 16-inch centres, you can see that where it starts flush on one side here, it's flush with the end, it lies 8 feet later right in the middle of a stud right there, so that the next piece of OSB can sit on here and have something to screw into, so it's not left on the edge like that, you know, flapping about, and it will carry on again 8 feet. In between we have noggins, and because timber tends not to be entirely straight, it kind of, as we've seen, it can bend either way, it can twist, and what the noggins do is create extra bit of strength and stop them bending and keep them nice and rigid down here. And this is about 2.4 meters, about 8 feet tall wall, and you just need the one noggin in the center so you can see the structure of the wall. This is a really simple wall. There's no windows, no doors, no openings, so you can just have the studs exactly 16" and keep on going. Going back to where the walls meet, this is the last stud, or the penultimate stud, and then this is where the next stud comes. I then cut the board there, and then this next stud, considering we want to have our OSB on the outside again, is 16" from this one, not this one. This is an additional one, so the space here is smaller than all the others. I'm continuing. Last thing to probably note is at the end, there's different ways of building corners. This is my favourite. This is the one I decided to go for. You can have this stud here on edge, so it's sitting like this. And the reason we have to have two studs like this is, yes, it's good to have extra strength in the corners, but we also, when the wall is upright and we have another wall butting to it at the corner, when we come to put in our inside sheathing, whatever it may be, like let's say plasterboard, that you want something to be able to nail into, and if you haven't got a stud protruding out from where the wall, the second wall meets, then you won't be able to attach your plasterboard to the inside, and the same will go for the next wall as well. So that's probably the easiest way. You just get to use your scraps as well, so you've got all this blocking that goes in between, and they sort of the offcuts that you have, so it kind of makes a really nice strong corner and uses up your scraps at the same time. But yeah, you go and look them up. There's California corners, there's lots of different ways, 2 stud, 3 stud corners, but you can check out, but this was on for me. So the last thing I did before I get to the sheathing, the last thing that I did is make sure that the entire wall is completely square, and you can obviously, because there's nothing, there's no bracing on it, which is what the OSB provides, the wall can sort of move like that. If you imagine holding it up and holding one of the 2 plates, you can imagine it sort of going like that. So what I did is, the best way to do it is to square it up on the floor, and by measuring the distance between there and then comparing it to the one here, and then if they're equal, then you know it's square, and if they're not, then you can move one way or the other and get it square. At that point, you can actually nail it through into your subfloor, into your floor joist. I've got, if you can see, a nail here that's going in at a 45 and just holding this in place so that it doesn't move around on me when I actually put the OSB on. And when I come to this stage, the OSB, what we will do is, obviously, because it's going between, it's going 8 feet and along a number of joists, it will hold that squareness in place. So then I can take these screws out, and I can then raise the wall without the fear of it racking one way or the other, and it will be perfectly straight, which is what we want for a nice square building. For attaching the studs to the bottom and top plates and the noggins as well in between the studs, I used 5 mil by 100 mil, so that's like 4 inches depth going into it. Screw these in with an impact driver. Before I put the sheathing on here, there is one thing I can do to make sure that my bottom plate is straight, and that is to put in a string line from one end and tack in something that you know is uniform in width, in this case a piece of plywood, and that pulls the string out by 18 millimeters, and the same on the other end. And then you can take another piece and just check all the way along that doesn't move the string in or out particularly, and you can see by eye, once it's still, how far it is off the bottom plate and whether it is indeed straight. If it turns out that it's not straight, then you can either pull the middle or wherever it may be that needs to be straightened in or out, and then tack it down to the floor with either a screw or a nail, and then that'll keep it straight while you put the sheathing on, and then when you remove them, the sheathing will keep it straight thereafter, and you know you've got a nice straight wall. So I've done one row of sheathing from the bottom, and before I do the top layer, I wanted to add my double top plate, so I'm adding the second one on top of here. The walls meet here where there's two different parts, so this needs to be given extra rigidity, so it's important not to have the double top plate also splitting here or anywhere near here. Good rule of thumb is a good sort of few feet, 4 feet maybe. So I've got it all running from one way all the way over to here where I started the second one. At the ends, because these walls go the full length of the building, and the walls that run that way will be sandwiched between the two walls like that. That means that I'm going to overlap the top plate on these walls over the two sides here and here. So I've left enough gap for that second top plate, which will run in that direction, to sit over there. And I've done the same on the other end as well, as you can see here. So I'm getting on with the sheathing for the back wall, and I just wanted to take you over how I'm doing it. The first thing is I'm using a product called OSB. That's oriented strand board, and it's 11 millimeters thick. It's OSB 3 rather than 2 is an exterior grade, so you can use it, and the price difference is pretty minimal, so it's worth upgrading to OSB 3. It comes with a smooth side, it's quite hard to tell, and a slightly rougher side, and supposedly the rough side should face outwards, but I think in reality it doesn't make much difference, but you should probably be consistent whichever way you choose. The layout of it, so just with the plywood floor, the joint should overlap. So where one board, two boards meet on one row, shouldn't have another intersection at the next one. So there should always be overlaps. These are two stud overlap, and you can do more if you're doing a much bigger project. You could try and do for 4 feet, but two studs is plenty, I think. So when you want to work your way, you start with the first one. It will always, if you've done your stud work correctly, it will always land in the middle of a joist, or sorry, of a stud, and it won't need to be the OSB won't need to be cut. Then you can follow with the second one, and then when you reach your third one, it will overlap the end, at which point you cut it off. And if it's big enough, if it's a decent sized section, then you can use it for the next row. As you can see here, this is the offcut from the end of the first row, coming onto here, and it really should be at least three stud bits, which this is. You can go 4, but I think 3 is fine. So the layout with the screws or nails is exactly the same as the floor. Around the perimeter, they're every 6 inches, and in the field, as I say, so 6 on the edge, it's 8 in the field. So where the studs are going through, which I've marked up with a line here, A lot of OSB doesn't come with the lines pre-marked in it. Some do, but because different people use different measurements. In the UK, some use 400 centres, 400 millimeters. That is. Others use 16 inch, like I'm using. They don't tend to come with these lines pre-drawn, so it's useful just drawing them on, and you can either measure from the ends to get the right markings on each end, and then to connect the line. Or in the case of the bottom row, I could just look on the outside of the stud, and I knew wherever I put my screws in for the actual stud to go into, that's where the stud lay. So yeah, you can use nails like here, or you can use screws, or you can use a mixture. Nails are cheaper, screws get them a bit tighter, so you can get the best of both worlds with using a bit of both, really. Probably the last thing to point out is that just like the plywood on the floor, the OSB isn't jutted up right against each other. There's a couple of mil gap in between, and that just helps if there's any movement that the two don't sort of come together. If there's water ingress, while the building's, before it's watertight, they can expand and start to bulge upwards, which you don't want. So maintain that couple of mil gap and you'll be fine. When the wall ends up vertical, if they're going through that way, then they usually you should tend towards nails, but if they're going vertically, there isn't that stress from the roof on them, and you can use screws. So I've screwed the ends vertically through, but then when it came to the header, you can see here that I've put in some nails as well, big ones that went all the way through. The header, I've done 3 fastenings. I've used a mixture of screws and headers, screws and nails, sorry, all the way through on 16 inch. Every 16 inches, I've done 3 there, and of course I've got another one at the bottom. So I've done the same here. So screwing up into the rest of the header. For the trimmers or the jack studs, these ones here, going into here again, 16 inches. So every 16 inches, and you can alternate it as well. So if you want to do 2 from this side and then 16 inches, 2 from that side, that's fine as well, and it gives you a good extra bit of strength. Where I did do that in some places. So moving on to the window, as I said, it's exactly the same structure, but obviously you've got a bottom as well. So you can see that we continue the stud layout. So where there's one at the top, where everything's on 16 inches, there'll be one at the bottom as well, and that goes underneath the sill plate. The sill plate doesn't need to be anywhere near as thick as the header, because it's only supporting the window. The header's supporting the roof. And then again, yes, you do want to have the cripple studs on the edges here as well. So I'll pan back and you can get a better overview of how this is made up. And I'll just go over to the final window, which is the shower room window. And just to point out, at the bottom here, it may look a bit odd. Why there sort of 4 studs right next to each other? Well, we've established that this one is the king stud on the left, runs all the way top to bottom. Second is the trimmer or jack stud up to the header, and the underneath of the header. Then we have a cripple stud, which has to line up underneath the sill plate as next to the trimmer. And then, because our 16-inch layout, it just turned out that, as we marked on our bottom and top plates, that there needs to be a stud here. So you can see that runs all the way to the top. So in fact, when you go to the top, there's one above the trimmer. There doesn't need to be one here because this is the top, and then this is your 16-inch layout. So now I've completed the front wall of the building, and initially it does look really complicated. Now it's complete, but the first thing to do was the same thing as the back, and that was just to mark out those 16 inches on centre, all the way marking from the left to the right in exactly the same way as I did for the back wall. And wherever those 16 inches on centre land, there is always some example of a kind of stud. So even though they may be very small, they still exist, and you can see them in the structure all the time, and that is for our cladding, so sorry, our OSB. So wherever it lands, we want something to screw into, even if it is small. So the challenge was obviously to put in 3 openings, one door, this is a double French doors, and then quite a large window near the centre, and then finally on the right hand side here is the shower room. Let me take the first example of the door. This is the one that I framed first, and the reason for doing that was I wanted to have the height of the windows and the windows on the same level, the same height as the door itself, so you can see that it's the same height, so that would look really nice and symmetrical from the outside. Obviously I could change the height of the window up and down depending on where the sill plate, this as you can see will be the bottom of the window, so the sill plate, that can move up and down, but the header needs to be exactly where the door is, and the door is a set height. So I've got one that was 2.1 meters high, which is 2100 millimeters, and that was what I used to get the height of the header, which is this, which I'll talk about in a bit. Of course, when you are doing it, you have to remember that although you frame with the bottom plate on, it will eventually, this will be cut out of the doorway, so we're measuring from the bottom, not from the top. So when we're doing what's called our trimmers or jack studs, which run from the bottom next to the opening all the way up to underneath the header, that we need to take into account that bottom plate. You also want to put in, and everyone varies on this, but I put in an extra 10 millimeters on top. So instead of being 100 high to here, it's actually 110 millimeters. So there's an extra millimeter, and that is just to be able to move it ever so slightly to get it completely plumb. So you need that little space when you get the doors to be able to move them around. And the same goes for the side to side. So this is a 1400 millimeter gap, but it's an extra 20 centimeters, and that is because I wanted 10 millimeters either side for that wiggle room. So basically the makeup of any opening is, I've already mentioned the trimmer or the jack, which is the first one that goes on the actual outside. On the outside of that, you have the king stud, which is a full stud like any other stud, and that runs right next to it and goes all the way to the top. The header actually distributes the weight of the roof down through the header and down the trimmer studs here, and because it's spanning quite a wide gap, it needs to be bigger. You cannot just put, well, you shouldn't just put a 2x4, depending on what roof you've got, across and hope it will be fine. I've over-engineered this. This is a 2x6, which is 150 by 47, finish size 145 by 45 millimeters, and I also went the extra step on the door of putting another 100 mil one underneath, just the same as the walls, and that's just to give it that extra thickness. On the windows, I didn't bother. I kept with the 2x6, which would be plenty to deal with a flat roof like this one. So when you're doing it, you obviously want to put as well as your 16-inch layout, you also want to have these are called cripples, these smaller ones, and you also want one above the trimmer, so that you've actually got 2 full length, sort of top to bottom supports that go all the way through and distribute that weight through. So wherever they lie, you'll always put an extra one on the end, either side of the header at the top. This is, in fact, this is an example where you've got 2. So the 16-inch layout comes and has a zip plate, so there should be a stud here, but then we also want to have a cripple stud here. If it was to say land here, then you just want to have one cripple stud. So I've just finished up sheathing the front wall. Couple of points to make. One is that the windows, you can't see them now because I have sheathed over the top, and that is to add rigidity to it, and later on, once they're standing, I'll cut them out. Obviously around the windows and doors, you'll want to go 6 inches with your screws and nails, whatever you choose, as if it was an edge. And also where you have a large door, like I've got here, it's a good idea to sheathe a full piece starting on the side where, or nearest where the door is, or if it's in the middle, then try and organise it so you've got a full sheet over the top. So if you can see where the door, I have marked it out, comes up like here and across. So this full sheet travels all the way up, sticks there, all the way down, and then that's where it finishes, down like that. So whenever I come round to cutting the rest of the door out, I've got a nice full sheet, continuous sheet that goes round and creates that rigidity still. At the bottom, got my socks on. At the bottom, I came to this. I had a full sheet, almost a full sheet on the end, which finished here, and then another sheet here which overlapped by about this much, and I wasn't going to go and get another sheet and start it from here and have it here and then end up with a cutout for this side and then a cutout on the other side as well. So instead I just cut a piece specifically for that area, and then I also, while I was at it, cut this out. So at least once all the walls are up, I can get in and out of the building through here before I end up cutting the rest of the door out. So this is what it looks like before the walls go up. Got the lads coming over later, and going to give me a hand. It's not a great day. The sun has just started coming out, and hopefully get these 2 walls up. I don't know how difficult it's going to be. Not done it before, so we'll see how it goes. So it was a lot of fun yesterday evening getting these walls up, and this is it today in a bit better light. It's really great to actually have them standing and get a good feel of how the room will be. I'll just take you around the back. That's what it looks like from the alleyway. They're supported by 3 braces, 1 in the middle and 2 at the ends, which go into the floor. So I've originally, before we stood the walls up, I put in 1 screw so it was able to move, and then tilted the walls slightly outwards, and that's to be able to lift the 2 end walls, this one and the other one, to be able to move them up without the walls interfering. After these are up, these can then be, the braces can be taken off and the walls can be level, be put plumb. So I put 2 at the ends, 1 in the middle. Now these, hopefully, I haven't done the measurements yet, but I don't think these will interfere with building the wall on the floor, so that's why I went for the middle. I also put in 3 screws down into the floor, 1 there and 1 at the end and 1 in the middle, and that's just to hold it. They're not particularly long ones, they're about they're 100 millimeters. I'm going to use 150 millimeter when I come to actually doing it, and I'm going to put them between every 16 inches basically, where between each stud down into it. I haven't done that yet because the walls need to be squared up, and only my front plate is 100% square, because my the floor isn't 100%. It's about a centimetre off across the width. So this one is flush to the front and exactly where it needs to be, so I could actually put some nails into this. One last thing to talk about with the sheathing that I was doing is, if you have a wall that's not as tall as this one, then you can lay 2 OSB sheets with the bottom overlapping. So if the OSB overlaps onto your floor joist, that can provide some extra stability, because you can screw in the the OSB down to the bottom, but I only had about a centimetre, so it wasn't worth it, so I just cut it off flush. But that is something you can do. One last change that I did make with the framing is that I took out the little, if you can see against the light, the cripple studs that were here, because when I did the string line test on this wall, it was bowing in slightly, and I think I cut my cripples too short, so instead I just hammered in a full piece instead. That's now a very, very sturdy wall, so that is good.